All right, so this review sheet here, let's see. So in the first problem, when you're deciding between factoring or square roots, what you want to look for is this. You see how this problem doesn't have a little x term like that? So that means you can do square roots, all right? This one has that x term. So if I was trying to take the square root of both sides, like what would I do with this? So I have to use factoring there. So I'm only giving you those two choices, okay? So like looking down here, I see this x term right here. I can't do square roots then. I have to use factoring. Here, I have a parentheses squared. I can get rid of the 12 and then do the square root to get rid of the square. I can go ahead and use square roots there. Okay. All right, so let's go back here and factor. 2, 11, and 6 have nothing in common, so I'm ready to break it up. For 2x squared, I got 2x and x. And what multiplies is 6? Let's try 3 and 2. So I'd have to put the 3 here and the 2 there. So that'd be 4 and 3. Well, 4 and 3 don't make 11, so that's not going to work. So now let's try 6 and 1. Can't put 6 here, so 1 and 6. And look, there's 12 and 1. That could be 11. My 12 would have to be negative, and my 1 positive for that to work. Okay, so when does 2x plus 1 equal 0? And when does x minus 6 equal 0? Remember, we have to solve. We have to get solutions here. So if I add 6, I'll get 6 for one answer. Take away 1 and divide by 2. So take away 1, divide by 2 makes negative 1/2. So negative 1/2 and 6. All right, over here, I'm going to do square roots. So I take away 5. So I get 3x squared equals 72. I'm going to divide by 3. So I get x squared equals 24. So I'm going to take the square root. Now, my answer is plus or minus radical 24, but I can reduce that. 24 is 4 times 6, and this has a perfect square root, so I'll get x equals plus or minus 2 radical 6. All right, over here, we're going to use square roots. So I'm going to get rid of the 12. I got x minus 4 squared equals, 36. Now do my square root. So x minus 4 equals plus or minus 6. Pop that negative 4, which becomes a positive 4. So 4 plus or minus 6, which means my answer is 4 plus 6 is 10. 4 minus 6 is negative 2. Okay, over here, let's see. I'm going to have to bring this negative 19x over to the other side in the middle. So 3x squared plus 19x plus 20. And these have nothing in common, so I'm going to factor like it stands. So 3x and x. Let's try 5 and 4. I was going to say 10 and 2. But I noticed that if I put 5 here and 4 there, this will get me 12x and dang it, and 5x, that's 17. Oh, never mind. Other way around, sorry. If I put 5 here and 4 there, that gives me 15x and 4x. There's my 19, so plus. All right, so remember though, when does 3x plus 4 equals 0, and x plus 5 equals 0? Those are my answers. This one is negative 5. This one is negative 4 divided by 3. If you can do that in your head, fine, but that's what you can do if you don't remember. Okay, using our quadratic formula next. Here's my quadratic formula. There's my discriminant. So it's ready to go with a, b, and c. I got 2, negative 5, and negative 1. My discriminant is b squared, so that thing. So negative 5, you always have to put parentheses, squared, minus 4 times a is 2, and c is negative 1. So we're just going to put that in our calculator. Okay. So we got parentheses, negative 5 minus 4 times 2 times negative 1. Okay, so 33. And we don't know that 33 is going to go inside the radical. So my answer, I got negative b, right? So a negative of a negative 5 is a positive 5. Plus or minus the square root of 33 over 2 times 2, which is 4. So there's my solution set. Right, over here in number 6, same process. I'm going to print that negative x over here, 5x there, so it's going to become positive 5x. So I got 4, 5, and negative 8. My discriminant is going to be 5 squared minus 4 times a, which is 4, and c, which is negative 8. All right, so let's see. So that becomes 153. Now 153 is prime. You could check it a little bit. 153 divided by 3. Oh, wait a minute, 51. It's not prime. Sorry about that. So 153 divides by 3. It makes 51. 51 divides by 3 again. It makes 17. So I can bring 3 out. So my answer, I get opposite of this, so negative 5 plus or minus. This is going to be radical 153 over 2 times 4, which is 8. But remember, I can break this down, bring a 3 out, so 3 radical 17 all over 8. These do not reduce, so that's it. Okay. All right, down here, I have to take away 2x. Like this looks ready to go, but these guys need to come over, and I'm going to add 3. So my problem is x squared minus 9x plus 8. So I got 1 for my a, b is negative 9, c is 8. My discriminant is negative 9 squared minus 4 times 1 times 8. So that is sorry, I was thinking for a minute. So that is 49. All right, that's going to be inside this radical right here. So I have my answer, negative or opposite of this would be 9 plus or minus radical 49 all over 2 times 1 is 2. So I know the square root of 49 is 7, so 9 plus or minus 7 over 2, not square root of 7, just 7. So look, 9 plus 7 is 16, and 16 over 2 is 8. So I'm going to get x equals 8. 9 minus 7 is 2, and 2 over 2 is 1. So there we go, 8 and 1. Right, over here, just some old factoring. These are perfect squares, so x plus 7 and x minus 7. These all divide by 2, so I'm going to pull that out and get x squared plus 7x minus 18. Then I'm going to have x and 9 and x and 2, because 9 and 2 make 18 and also make 7, plus and a minus. Right, on the back side here, so my parabola here, I'm going to fill in my vertex, 3, negative 1. Over here, right side going up, so infinity and infinity. And over here, negative infinity and infinity, because left side going up. All right, my vertex is 3, negative 1. My domain, this thing goes out forever, so negative infinity to infinity. My range, my lowest, so my lowest y, and then my highest y, so negative 1 to infinity. All right, increasing, that would be this side here. So from this point, so from 3 over, so 3 to infinity. And everything before 3 is decreasing, has a negative slope. So from negative infinity to 3. The x-intercept in an ordered pair would be 2, 0 and 4, 0. Y-intercept, I can't really see the y-intercept, so you know what, we're going to get that later on after we do the equation. All right, the zeros, I got 2 and 4, so x equals 2 and 4. And behavior, both ends go up, so infinity, infinity. All right, my equation, let's see. So notice there's my vertex. It's going 1, 1, 2, 4, so there's been no stretch. So it's going to be y equals, I'm going to put x minus 3 to make it move over to the right 3 squared, and then minus 1. So let's go back to this old ordered pair here. the y-intercept. The y-intercept is whenever you plug in 0 for x. So I'm going to do that. So I got 0 minus 3. Oops. 0 minus 3 squared minus 1. So it's going to be negative 3 squared, so 9. 9 minus 1 would be 8. So that would be 0 and 8. Or you can also, look at, graph this in your calculator and look at it. All right, so change the vertex form to standard form, but first of all, the vertex, left 5, down 8. So negative 5, down 8. And changing it to standard form, that just means working this out. So x plus 5, written twice, minus 8. So this becomes x squared plus 5x plus another 5x plus 25 minus 8. So x squared plus 10x, 5, so 17 plus 17. So let me put h of x equals x squared plus 10x plus 17. And one way you could check yourself, you could plug in the original, like go to y equals and type in x plus 5 squared minus 8. And go down here and type in x squared plus 10x plus 17. And, oopsie, hang on. And you should see the same graph appear. Well, you don't see a second one, right? So you know it's the same, right? And what you can do actually is you can go down here, and if you go over to the left, you press enter and it makes it like a thick line. So that way when you graph the first one, the second one is like a nice thick line, so you can kind of see the difference. Okay. All right, I'm going to reset my calculator. Okay, find the vertex. Remember to use this formula. So the question would be just like this on your test. So remember the b value is there. So negative b, so the opposite of b, so it would be positive 8 over 2 times 1, which is 2. So that's 4. And to get the y value, I got to plug 4 into this. So 4 squared minus 8 times 4 minus 20. So 16 minus 32 minus 20. So it's negative 16 minus 20, so it's negative 36. Or use your calculator. So you got 4, negative 36. Okay, so here I'm supposed to use the factors to identify the zeros. So if I factor this, x and x, 10 and 2 are going to work out here. So minus 10 and plus 2. So it means my zeros, when does this equal 0, are positive 10 and negative 2. Okay. All right, this last question is back to the quadratic formula. So when Keaton was doing the quadratic formula to solve a quadratic equation, he calculated the discriminant. So that means that we're talking about this part in here, this discriminant, like that part inside the square root. All right, and it came out to a negative 12. So if that's going to be negative, that means you're not going to get any real answers. You're going to get 2 imaginary answers. So you're not going to get 2 real, you're not going to get 1 real, you're going to get no real solutions. And so that also means that your graph will never touch the x-axis. It'll either be like up here, never touching it, or it could be down below it and just never touching the x-axis. Right. And that is it. Bye-bye.